Chapter 15: The Resonant Leap. Imagine our Sun and the whole collection of planets including our Earth orbiting the Sun. Atoms have similar properties, and around the nucleus, electrons orbit. These orbits, which the electrons had, were fixed, and they could only orbit these. When the electrons were heated and became agitated, they could jump from one of their fixed orbits to another orbit, and as they do so, they would release energies of light in specific wavelengths. These wavelengths would also give off very specific colors depending on their orbit, and the very act of jumping from one orbit to another gave us the familiar phrase we understand today as the resonant leap. The electrons, in their agitated state, could leap from one orbit to another, and more importantly, they could do this without inhabiting the space in between. How could this be possible? Previously it had been thought that matter either had to be here or there, and if, like a train, it moved from station A to station B, it inhabited in its journey the world in between. But this was not the case with the tiny electrons. They could move from station A and jump to station B without being present anywhere in between. In order to understand more these bizarre properties of electrons, science put together the double-slit experiment. Imagine firing balls through a solid plate with two slits in it. The balls would either hit the plate or go through one of the slits. Placed on the other side, behind the plate, was another solid plate, and the balls which had passed through the slits on the front plate would now hit this second plate standing behind it. You would imagine that each ball passing through the slits would leave a line or pattern on the plate behind, depending upon which slit they had traveled through. They would hit the plate directly behind either the right slit or hit the plate directly behind the left slit. What science did was to substitute the balls for electrons and sat back to see if they behaved in exactly the same way as the balls had done. They were amazed to discover an entirely new way. Instead of the particles hitting the plate behind the slits in their respective lines, the particles appeared to strike the plate anywhere. The particles behaved as though they were waves and not particles. The marks they made on the plate behind the slit resembled the way a wave would behave when passing through. The wave would be a single mass before it hit the two splits, but as it passed through both slits, it would divide into two separate waves, and only on the other side would the two waves once again combine their peaks and troughs and move forward to hit the plate behind. The pattern the waves made was an interference pattern, whereby the waves had combined their forces. The question raised now was, how could the electrons, which were particles, behave like waves? A particle is a particle, and a wave is a wave, and they have to be one or the other, as they cannot be both. But can they?